students, and welcome to Eduauraa. It's once again Mohammad Farooque, your chemistry expert. Okay students, let us move into the moderate level of questions for the entrance exams. Going to the first question, the charge of an electron is 1.6 into 10 raised to minus 19 coulombs. What will be the value of charge on Na plus ion? Now Na plus ion is formed by the loss of one electron. So when it loses one electron, the charge on it is a positive charge. That positive charge will be equal to 1.6 into 10 raised to minus 19 coulombs, which is the first answer. Yes? Let's move to the next question. The specific charge for positive rays is much less than the specific charge for cathode rays. This is because the positive rays and the cathode rays are negatively charged particle, positive rays are anode rays. The charge is less than that of cathode rays. Why? If you see the choice C reads that positive rays comprise ionized atoms whose mass is much higher. Therefore, the choice C is a suitable answer for that question. Moving to the next question. If S1 be the specific charge of E by M ratio of cathode rays and S2 be that of the positive rays, then which is the true statement? We know that S2 is less than S1 or S1 is greater than S2. Choice B is the correct answer. Next question. The massive particle among the following is, massive means heavy particle. Which of the following is considered to be the heaviest particle? The heaviest particle from the choices you can decide, students. Alpha particle, because its mass is 4 units and charge is 2 units. So alpha particle is the correct answer. The next question is, the ratio between the neutrons present in carbon atom and silicon atom with mass number 12 and 28 is respectively. The ratio between the neutrons. In carbon, the number of neutrons are 6. In silicon, the number of neutrons are how many? 14. So what will be the ratio of 6:14? Divide by 2, you will get 3:7. So the correct answer of neutron ratio is 3:7. Next question. Transition of electrons from M shell to K shells results in the emission of. M shell is the higher shell, K shell is the lower shell. So transmission of electron from higher to lower results in the emission of ultraviolet radiations or ultraviolet rays. Choice C is the correct answer. Okay, moving to the next question. Which of the following transition H with colored spectral line? Okay, which of the following transition will give you a spectral line which is colored? If you see that, choice B, when there is a transition from shell 4 to shell 2, that is n is equal to 4 to n is equal to 2, you see colored spectral lines. Next question. Value of N1 and N2 for hydrogen spectrum emission is given as. The emission of hydrogen spectrum, when the values of N1 and N2 are given to you respectively, you will use Rydberg's expression, that is 1 upon lambda is equal to Rydberg's constant RH, which is equal to 1 upon N1 square minus 1 upon N2 square, and the answer should come in between 2 and 4. Yes, that is choice D. Next question. The ratio between potential energy and total energy of an electron in hydrogen atom is according to Bohr's model or Bohr's atomic model. Okay, the ratio is given as choice D should be the ratio, that is 2:1. Next question is, the number of radial nodes, nodal planes for an orbital with n is equal to 4 and L is equal to 1. Nodal planes and number of radial nodes. How do you calculate the number of radial nodes? Number of radial nodes is equal to n minus L minus 1. Radial nodes will be equal to n minus L minus 1 gives you the number of radial nodes. Yes, and angular nodes is equal to what? Angular nodes is equal to L, and number of nodes will be equal to n minus 1. Keep these formulas in mind, students. Number of nodes is equal to n minus 1, angular nodes is equal to L, and radial nodes is equal to n minus L minus 1. So using the formula, you can find out and you will get choice B, that is 2 and 1 respectively. Yes students, Formula is used, substituted, we know the value of N and L given to you, substitute and get the correct answer. You can do this and come to the correct answer. Let's go to the next question. A 3D electron is having S is equal to plus half, can have a magnetic quantum number. Now magnetic quantum number ranges from what? Magnetic quantum number ranges from +2 to +1, 0, -1 and -2. These are the quantum numbers for a magnetic quantum number, right? So from the choices, which will be the magnetic quantum? The correct answer will be +2 for an electron with +half spin, right? Next question. The set of quantum numbers not possible to an electron is. Which are the choices which cannot have the following set of quantum numbers? That is choice A, if you see, that is 1, 1, 1 and +half. That means when N is equal to 1, L should be equal to 0. L cannot be equal to 1. And when L is equal to 0, M should also be equal to 0. So it's not matching in choice A. So A is inappropriate answer. Moving to the next question. If Pauli's exclusion principle is not known, then the electronic arrangement of lithium atom is. If Pauli's exclusion principle is not applied, then what will be the electronic configuration of lithium atom? Lithium atomic number is 3. Actual electronic configuration is 1s2, 2s1. But if you don't apply Pauli's exclusion principle, then the correct electronic configuration will be 1s3, which is the wrong substitution, but the correct answer is C as per the question. Moving to the next question, the question reads that the valence shell electron for configuration of an atom is 4s2, 4p5. The question is the maximum number of electrons having parallel spin in this configuration are. 4p5 is the outer shell configuration. In 4p5, it is distributed as what? 4px2, 4py2 and 4pz1. That means there are 2 pairs of electrons. That means there are 4 electrons with parallel spin. So choice B should be the suitable or the correct answer. Moving to the next question. Magnitude of deflection of cathode rays in a discharge tube is more when? When is the magnitude of the discharge of the cathode rays? When is the magnitude of deflection of cathode rays in a discharge tube? Look at the choices and decide, students. When will be the deflection greater in case of a cathode rays? If you see that all of the above answers are supporting the maximum deflection of cathode rays in a discharge tube. All the choices, if you read them one by one, all of them the factors which support. Moving to the next question. When the speed of the electron increases, the specific charge. When the speed of an electron increases, the specific charge, what happens? Decreases, right? So A is the correct answer. So that's the relation between specific charge and speed of an electron. Next question. The magnitude of deflection of cathode rays in a discharge tube is more when? When is the magnitude of deflection more? We have just seen a question related to this again. If you see that less mass of the particle, when the mass of the particle is less, deflection will be more. When the mass is more, deflection is less. So choice C is the correct answer. Next question. The E by m value of a proton is. The E by m value, that is charge to mass ratio for a proton, is less than the E by m value of an electron. Yes. Why? Because the charge of a proton is greater than electron and the mass of a proton is also greater than electron. So the ratio will be less. Yes, it will be less. Moving to the next question. Next question says, for the atomic radius of the order of 10 raised to minus 8 centimeter and a nucleus radius of the order of 10 raised to minus 13 centimeter. Okay. Radius of the nucleus is given to you. Radius of the atom is given to you. The fraction of atom occupied in the nucleus will be what? What is the fraction of atom to that of nucleus, students? Okay. You have to find out the ratio of radius of nucleus to the radius of atom. They given you the radius of atom and that of the nucleus. So you have to find out the ratio of atom to nucleus, and if you see that the ratio should come of the order of 10 raised to minus 15 x atomic value. That means 10 raised to minus 15 times the atomic volume occupied by the whole nucleus as well as the atom.